Okay. So far, what we've gone through is we've only looked at uniform rods. So every time we've had a bridge or whatever we've been looking at, we've always had the mass acting and the weight acting from the very middle, because we've assumed that it's the same throughout, so therefore the centre of mass has been at the middle every time. But now we're going to look at sometimes when we're using a non-uniform rod, so the centre of mass does not necessarily have to be in the midpoint. Okay, it could be somewhere else. So we treat everything else exactly the same, it's just that the weight acts at a different point, not necessarily the middle. So we have a look at this example. Looking at sitting on a seesaw, basically, and I'm going to do a sketch of it below, just so I don't have all these people in the way. And on my sketch, I'll just have the forces. So here's the seesaw, and it's got some sort of support at the midpoint there. So Sam and Tasmin are sitting on a non-uniform plank from A to B. So I'm just going to label those ends A and B. Of mass 25 kilograms and length 4 meters. So the mass will be 25g, but we don't quite know where yet. It's 4 meters long. And the plank is pivoted at M, the midpoint of AB. So I know that there's 2 meters all the way to there and 2 meters all the way to there. The center of mass of AB is at C, where AC is 1.8. So I'm going to say the center of mass is here. So my 25g acts down there at that point where the center of the mass is. And this distance to the center of mass is 1.8 meters. Sam has mass 35 kilograms. Tasmin has mass 25 kilograms and sits at A. So she sits on the end. So we've got 25g acting down here. And we want to know, where should Sam sit? So Sam's going to sit somewhere along this side. So let's just place him anywhere for now. I'm going to assume he sat there, this random point. That's his 35g. And I'm just going to call the distance between the pivot to him. That's going to be my distance x. That's what I'm looking for. X there. So I've put on the weight of the rod, the weight of Tasmin and the weight of Sam, but I've still got a reaction force, which will be here at this point. So I'm just going to call that R. So that's going to be acting upwards. And we could quite easily work out what that is, but there's no need to. We don't need to work out what R is going to be. What I am going to do, though, is I'm going to take moments about that midpoint there, about point M. And I know, because we want the plank to be horizontal, we want it all to be in equilibrium, any moments going anti-clockwise will equal any moments going clockwise. So taking moments about M. And I know if I'm taking moments about here, clockwise, I've got this 35g. That's going to be my clockwise moment. Anti-clockwise, I've got these two here. Those two forces going down are my anti-clockwise moments. So clockwise, 35g multiplied by x is equal to the anti-clockwise moment. So 25g times, and that's going to be 0.2, that distance. Plus 25g times 2. So all I've said is clockwise moments equal to anti-clockwise moments. And I'm solving for x. So x is equal to all of that, 25g times 0.2 plus 25g times 2 divided by 35g. So if we can solve that, we'll solve for what x is going to be. We can probably cancel out all those g's to make things a bit less confusing. So I've got that x is equal to 1.57 metres. So the question really says, where must Sam sit? So I'm going to say Sam must sit, if I do it from A, I'm going to say he needs to sit, that would be 3.57 metres from A. So 3.57 metres from end A. We're sitting down here somewhere. So that was really similar to questions we've done, apart from the fact that the centre of mass was somewhere different, not just in the middle of the rod. Okay, next question is really similar too. So it says, a non-uniform rod is 3 metres long and has weight 20 newtons. It's in a horizontal position, resting on supports at points C and D. AC is 1 metre, AD is 2.5 metres, and it tells us a bit about the reactions. The reaction at C is 3 times the reaction at D. Find the distance of the centre of mass of the rod from A. We definitely need to do a bit of a diagram here. So draw yourself a rod, and it's got 2 supports, support C and support D. So this is end A, this is end B. I'm going to call this point C, this point D. We were told that AC is 1 metre, so 1 metre for that section. AD is 2.5 metres, so the middle bit is 1.5 metres, and then this last bit here is, that's 3 metres long, so that's 0.5 metres. And what else do we know? We know that, yeah, it's 3 metres long. Let's put some of the forces on. We've got a reaction at C, which is 3 times the reaction at D. So if we call the one at D R, we can call this one 3R. And then we've also got the weight acting. We don't know where it's acting, so I'm just going to put it here. That's 20 newtons. And I'm just going to say that distance from the end to there is X. And that's what I need to find out, where the centre of mass is, what the distance X is. Okay, start off then. First thing is vertical equilibrium. So forces up equal forces down. So I've got 3R plus R, which are the forces up, equals 20 newtons down. And I can therefore solve. So R is going to be equal to 5 newtons. Nice and easy. And then we've done vertical equilibrium. So next is going to be moment equilibrium. And I'm going to say the moments clockwise are equal to the moments anti-clockwise. So we know, taking moments, you could take them around any point you want to at all. I'm going to take them from the point A. So taking moments about point A. And I'm going to do that because I know that will help me work out X nice and easily. You could take it from anywhere else, but you would have a different answer for X and then just have to sub it in the end. So taking moments about A, clockwise, I've got that 20 newtons multiplied by the distance X. So 20 times X. Anti-clockwise, well, I've got 3R times 1. I remember we worked out that R was 5. So that's 15 times 1. And I've also got R, which is 5, times by 2.5. And then we just need to solve this for X. So X is equal to 15 plus 5 times 2.5 all over 20. So I get 1.375 meters. So we're saying x here, that distance x is 1.375. And the question says find the distance of the center of mass from the rod, from A. And that's just what we've done. So we can say the center of mass is 1.375 meters from end A. And I've just used that to represent center of mass. Okay, so these questions are always the same as what we've been doing before, apart from center of mass isn't necessarily in the middle. So hopefully you can now have a go at exercise 4D questions. This is the last one of this chapter.